All right, so 1-7 is finding inverse functions, well, inverse relations and their functions, okay? So you guys have done this before. It's going to be a little bit more in depth this time, though. So step 1, let's do just simply finding an inverse. All right, so in order to find an inverse, all you are going to do is simply switch the x and the y, and then solve for the y.
Oh, yeah.
Okay, good. So notice right now I don't have a y written. So what is really my y? My f of x, right? Okay, I'm still going to use a y when I switch it because y looks easier to solve for than an f of x. So I'm going to start by doing x is equal to 2y cubed minus 1. Well, I don't know why I wrote that up like that. Let me rewrite that. There we go. Okay, so all I'm going to do is solve for y at this point. So how do I do this? What are my steps? You add 1, divide by 2, and then cube root it. So do we all agree the inverse is the cube root of x plus 1 all over 2?
Yes.
Okay. Do take a quick note at the notation for inverse. F to the negative 1 is a notation for inverse. Okay, it is not an exponent, it is a notation. Yep, if they start with a y, absolutely, yes. Let's do one more. Okay, so given that quadratic, how do I find the inverse? Okay, what do I do right before that, though?
Wait, what are you doing?
Switch the x and the y. So make sure you switch first. So x is equal to negative times the quantity of y plus 2 squared plus 4. Okay, so how would I solve this one for y? Subtract the 4, so I have x minus 4 is equal to negative times the quantity of y plus 2 squared.
Then would you negative or the x?
Okay, you got to get rid of the negative first. So divide by negative. So I have negative x plus 4 is equal to our quantity of y plus 2 that is squared. Good, then I square root it. So now I have the square of negative x plus 4 is equal to y plus 2. And then subtract 2, good. So can I switch the sides here? Is that alright? So I'll have negative square root of x, or the square root of negative x plus 4, and then on the outside minus 2. Minus 2. Okay, and you cannot simplify that any further. That's as far as you could go.
This is all we're doing.
Kind of, yeah. But yes, only dealing with inverse. Well, I'll show you. Alright, so the second half to this is graphing. So they want you to be able to find inverses graphically. So I'm going to show you what happens here. So I'm going to make that a minus 1. There we go. Minus 1. Okay. So, how would I find it algebraically? Okay, so we switch them.
X equals negative y plus q minus 1.
Okay, what do I do next?
And then you're gonna
Bree, are we good over there?
and then you're gonna add the 1.
Okay, so add 1 first.
So x plus 1 equals negative y plus q.
Okay, then
Take
what?
away the negative.
Get rid of the negative. So can I just go, shh? Where are you guys going? Cube root it. So we got the cube root of negative x minus 1 equals y plus 3.
And then subtract 3.
Subtract 3.
Negative 1 of x equals cube root of negative x minus 1
Good.
minus 3.
All right, so what I want you guys to see graphically is there is a relationship between a function and its inverse. Okay, so I'm going to pull up Wabbit here
Wabbit.
and graph these. Maybe. This might work.
You have so many calculator apps in this whole game.
Why can I not open Wabbit? I just want to use Wabbit. My calculators.
I get it now.
Okay, so I'm going to type the original and also the inverse into the calculator. Okay, and I want to see if you can see the relationship between the original function and the inverse. Okay, so I'm going to type negative x plus 3 to the third minus 1. Okay, and then also the inverse, so I'm going to do math and choose number 4 for the cube root of negative x minus 1. Push the right arrow to get out from under the radical, minus 3. Okay, everybody watching? Can everybody see that graph? Okay, so I'm going to hit zoom 6, make sure I'm in a standard 10 by 10. Okay, you should see John Travolta. Okay, with his left arm down, that's the original. Okay, now it's drawing the cube root piece. Okay, so what really happened?
No, it's reflected too.
There is a reflection.
Isn't it? Yeah. I don't know.
Okay, maybe it would be useful if I also graphed question number 1 on here too. Excuse me. Okay, so let me throw number 1 on the same graph and see if you can see it here. Okay, so again, I'll have a John Travolta for the original, right? So I'm going to hit math and do number 4. And I'm going to do a fraction inside of this. X plus 1 over 2. Okay, here comes the other ones. Okay, so there's a John Travolta. And another John Travolta. Interesting. So can you guys see what's happening? turn it and flip it. Okay, let me show you something here with, let's see if I can take a little screenshot of this. Okay, so do you guys see those points of intersection?
Yeah. They're kind of everywhere.
There's actually only 2 points of intersection. Actually, let's use it right here and right here, between the inverse and its function, its original. Okay, so here's an original, here's an inverse. Okay, here's an original, and here's its inverse. Okay, if I connect those 2 red dots and create a line out of it.
Oh, it's reflects across the
Exactly. This red line is y equals x. Okay, all that is happening is the function is being reflected over that line.
That's right.
Okay, so here's a question. What's that? Always, because if you think about algebraically, what did we do initially? Our first step was to do what? Set y equal to x. Exactly. Okay, so that is exactly why the graphic is reflected over that line. Okay, so let's do another graph. Let's say I'm going to see if you guys can do this. I'm going to even draw in your reflection line. And my function is going to be green. Nope, that's not green. Okay, so let's pretend you have this function that's a parabola. That is a parabola. Okay, can you imagine reflecting this parabola over the y equals x line? What would it look like? But what does it look like?
Sideways, whatever, like that. Yeah.
Can you draw it? Okay, nice. Okay, so this is actually a very good reflection. Okay, this is exactly what this would reflect to. So if this point right here, let's just say this point was -2, 3, pretend. -2, 3. Okay, this point right here would become what? 3, -2. You just switch the values, right? Okay, now what's wrong with the function that Chance drew? It's not a function. Okay, it is technically not a function. Okay, so this is the deeper part of the inverses. Okay, at some point, a function may possibly not have an inverse because it doesn't pass the vertical line test. Okay, so what's going to happen is you're going to see something like, what number am I on? Number 3? 4. Number 4. Like this. Okay, and what's going to become really important is stating the domain and range of these functions. Okay, because initially there could be a restriction in order to make the function's inverse actually exist.
Like that one.
Okay, so this one doesn't have a restriction at this point. So if this was given, first let's start by listing the domain and the range of this function. Okay, what is the domain of this? You guys remember how to find domain? Okay, so remember there's only two ways to restrict domain. One way is to divide by an x. You can't divide by 0. Are we dividing by an x? No. Okay, the second way is to have a square root involved. You cannot take a square root of a negative number. Do I have a square root involved? Yes, so how do you find the domain when there's a square root? What do I do with the inside of the square root? Okay, you have the right idea. It cannot be negative. So how do I state that as an inequality?
It has to be greater.
It has to be greater than or equal to 0. Okay, so if I take the inside and make it greater than or equal to 0, what is going to be my domain for this? Okay, x has to be what? Greater than or equal to 4. So the domain has to be greater than or equal to 4. 4. Okay, let's talk about the range. The range you generally get from graphing this function. You guys remember what the graph of this would look like? What does square root look like? It's the top half of the parabola on its side, right? So we got a top half, but we have a minus 4. So what direction would it go? To the right 4. 1, 2, 3, 4. Okay, if I'm talking about the range, I'm talking about the y values. Okay, what is the lowest y value that it exists at? 0. What is the biggest? To infinity, right? So it starts at 0 and it goes up, 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 up very slowly, but still goes up. So all values greater than or equal to 0. Everybody get on the range.
Yes.
Okay, so now what I'm going to do is I'm going to do my algebra to find the inverse of this function. Okay, so how do I find the inverse? Okay, so I switch the x and the y. Okay, and I'm going to solve for y. So what's my first step?
Square root.
What? Square.
Or square.
So x squared is equal to y minus 4. And then I add 4. So my inverse is going to be x squared plus 4. Okay, now check this out. Okay, if I was going to take this graph, okay, imagine its inverse. Can you imagine it? Let me draw the y equals x line. What would the inverse of this graph look like? Parabola up 4, but we're specifically about the parabola. It's not a whole parabola. It's like the right arm of it.
Right.
Okay,
Going up from
up 4. But my function, what does this look like?
that.
That looks like a parabola. Okay, so all I'm going to do is I'm going to state the restriction that I was given from this. Okay, so my inverse function is going to be x squared plus 4, and the domain has got to be x values greater than or equal to 0, and my, whoa,
Wait,
okay.
how do I switch?
My range is y has got to be greater than or equal to 4. It's switched. Why is it switched?
Oh,
It's the whole point of the inverse, right? We switch the x and the y. It's exactly what happens with the domain and the range. Okay, so now my restriction on the domain is x is greater than 0, which makes sense on the graph. And my y has got to be greater than 0, or excuse me, greater than 4. Okay. So everybody okay with those?
Yeah.
Okay, so heads up. They're going to say, find the inverse state restrictions. When are you going to see restrictions occurring? What kind of functions, when turned on their side, so reflected over the y, are you going to see those on? On what? Quadratic. So if they say, find the inverse of this quadratic, you're going to have to be careful because there's going to have to be restrictions. Okay? Square roots involved. What about cubics? John Travolta's. Are there going to be restrictions? Those didn't have any restrictions. Remember, I graphed those in the calculator. Those absolutely worked, original and inverses. Okay, so it's only things, although some John Travolta's could create restrictions, like if your original was like this, right? Because if you flip that on its side, it would be like, well, that's a really good drawing, but anyways. Yeah, it looks like a bunch of S's. Okay, but if there's up and downs of your original John Travolta, its inverse has got to be restricted. Okay. So, hold on, I got one last thing for you. Ooh, here's one more. Hold on, I better do this one example. What are we on, number 5 now?
Yeah.
Okay, this is a tricky one, so let me give you this example, because you'll see one in your assignment. Okay, so this one is kind of gnarly. Yeah, there is a vertical asymptote. Okay, so if I state my domain in my range, what's the one value that x cannot be? What value makes the denominator 0? So just -2, right? So x cannot be -2. Okay, since I have a function that is written as a fraction, a rational function, I have to think about horizontal asymptotes. Okay, so remember horizontal asymptotes? So I'm looking at the leading term on the top and the bottom. Is it bigger on the top, bottom, or same? Same. So where is my horizontal asymptote if they are the same? What's the number in front of these? What's 1 over 1? Today it's 1. Tomorrow it's 1. Okay, so the y cannot equal 1. Okay, now let's do the algebra on this. This was a little bit difficult. Okay, so finding the inverse, switch the x and the y. Notice there's 2 x's. So we're going to have y minus 1 and y plus 2 on the bottom. Okay, we're solving for y. First thing I need to do, get rid of the denominator. How do I get rid of it? Good. Multiply both sides by y plus 2. Okay, what am I going to do on the left-hand side? Distribute xy plus 2x equals y minus x. Okay, remember I'm solving for which variable again? The y, so I need to get the y's all on one side.
Times y minus 1 times y.
Because that's what eliminated this one. And multiplied it to the other side, essentially. Right? So,
Wasn't it the same as timesing by y plus 2 over 1?
yeah.
Yeah,
Over
so
1.
the top
Yeah.
would be weird and 1.
But I have a y plus 2 on the bottom, so they cancel out. Top and a bottom. They cancel out. Properties of multiplication. What? I mean, kind of, yeah. If you're thinking of it as multiplying by a reciprocal, you can think of it as dividing by 1. Because y plus 2 would be the same as y plus 2 over 1. Oh, y. I think I said 1. Divide by y? Where? On this step?
No, on the bottom. Instead of subtract.
Oh, no. You subtract. Because this is being subtracted to the other one. Yeah, it's added. So you don't divide. Only if this was being multiplied by the minus 1. What?
Yeah, I'm giving you take xy minus 1.
xy. Well, you can't combine them yet. Hold on, I'm not done. Are you guys? Let's wait. So I got xy minus y plus 2x equals -1. Are we still lost?
That makes more sense.
But I'm not done yet. Now I subtract 2x. So x, y minus y was -1 minus 2x. Okay, remember which variable I'm solving for? How do I get y pulled out by itself? If I have a y in both of those terms. Okay, so it's kind of like dividing. I'm going to pull it out like a greatest common factor. Similar in idea. So if I pull this out, what's left over if I divide by y? X minus 1, very good. I didn't touch the right side. Okay, I'm almost done. I have y times some stuff. How do I get rid of the stuff? Divide by the stuff. So my inverse, my y, is -1 minus 2x over x minus 1. What are my restrictions? What can x not be? What is my range? Y cannot be -2.
Wait, why can't I?
Okay, there's going to be a horizontal asymptote. Okay, for two reasons. Number one, if you go back to the top and you just flip your restrictions, that's going to be the easy way to do it. If we go back to the bottom, bigger on top, bigger on bottom, we're looking at -2x over x. That's the same, right? And so I have a -2 over 1. So I have a horizontal asymptote at -2. That's probably the hardest kind of problem you'll see. That is a tough one. Playing with fractions. There is one more example of this. It's verification. This is quick. So I might not even give you an example of this because I'm killing Skyla. So to decide if you are in fact finding the inverse, all you have to do is do a FOF. And if the FOF is equal to x, then it is a verification.
Wait, what do you mean?
Okay, so example. So can I use example 1 to do my verification?
Yeah.
So using example 1. So if I go back up here, what was my example? Okay, so my original was 2x cubed minus 1. Here, you guys tell it to me. 2x cubed.
Oh, so you just put the inverse in.
2x cubed minus 1. And the inverse was what? The cube root x plus 1 over 2. So your verification is to do a FOF. So you plug, it doesn't even matter which one you plug into the other one. You can go either way. So if I do a FOF and plug the inverse in, okay, so I'm plugging that into that piece right there. So it's going to be 2 cube roots of x plus 1 over 2 cubed minus 1. Okay, so immediately you have a cube root cubed. So what happens on a cube root cubed? They cancel, so you get 2, and then you have times x plus 1 over 2. So then what can we cancel? If we have 2, and then a 2 in the bottom, the 2's can cancel. So I have x plus 1 minus 1. So it's x. So that's a verification. Yeah. So we good? Oh, that's hard. Sure. Which one do you want me to do it on? The last problem? But like what function should I verify? Let's not do number 5, that could get gnarly. How about number 4? Can I verify that one? So we got the square root of x minus 4 and x squared plus 4. So the original was the square root of x minus 4. The inverse was x squared plus 4. Okay, so your verification is a FOF. I'm going to plug this into that. Right? So I'm going to go x squared plus 4 minus 4. And then just simplify. So I can simplify what's on the inside. So if I have x squared plus 4 minus 4, the 4's cancel. And I have the square root of x squared, which gives you x. So as long as you get x, that's verification. Okay. All right, so let's get to work.